Hey y'all, this is Mr. Parker, and as I stated in my last video, we stopped at a fraction that I said that we were going to later reduce. So today, our objective states I will be able to reduce fractions using factor trees. Now you might be like, what? How you going to reduce fractions using factor trees? These are two totally different topics. We talked about prime and composite numbers last week, and we talked about factor trees and stuff like that, and how are fractions and factor trees and prime and composite numbers, how are they even related? Well, we're going to talk about that, but first we're going to answer a couple questions. What is reducing fractions? It's just finding the least common equivalent fraction. So if you have a number like 2/4, and I'm kind of jumping the gun, but 2/4 is the same as 1/2. They're the same thing. So the least common equivalent fraction would be 1/2. Or we'll take something like, we'll take 16 30 over 32. Well, if we do that, we see that the least common equivalent fraction again will be 1/2. So how do we get to this 1/2, and how do we know in times where we'll have to actually reduce the fraction, or if the fraction's able to be reduced? Here's the next question. Why should I reduce a fraction? Well, it's simply to simplify your answer. Um, and let's just be honest, sometimes you'll do all the math like we did in our last video, where we converted a mixed number to an improper fraction so that we could subtract it, and then after we got our answer, we saw that our answer was an improper fraction, so then we had to go back and convert that improper fraction to a mixed number. So you don't want to go through all of that math to get an answer that's correct, but then get confused when selecting the answer because you don't recognize the equivalent fraction. So we ended up with a number on one of our examples that said 2 6/8. It was a mixed number, 2 6/8, but we see right here that the 6/8, I know that 6/8 could possibly not be a the most simple or the least equivalent fraction. How do I know that? With my understanding of prime and composite numbers, I know that both 6 and 8 are composite. How do you know, Mr. Parker, that 6 and 8 are composite? Well, because in our earlier video, we stated that all even numbers, if y'all remember this, all even numbers, you know what? I'm going to go ahead and make your note take it easy. All even numbers after the number 2 is or are composite. Are composite. They all are composite, which means that they have more than just two factors. You can factor it out with and multiply two numbers to get the answer. So it'll be more than just, so as we see for 6, we can do more than just 1 times 6 to get our answer. We can do so much more than that. So let's go ahead and take this 6/8 and we're going to reduce it. So we'll go ahead and draw our antennas from our 6/8. Go ahead and write that. And when we look at 6/8, we know that since it's an even number, we know that it has to be divisible by 2. What number would you multiply times 2 to get 6? It'll be 3. Okay, leave that right there. We'll do the same thing with the 8. So when we see this 8, we're going to try to see, is it also divisible by 2? Yep, it is also divisible by 2. And what do you multiply times 2 to get 8? That number is 4. So our new reduced fraction, this is going to blow your mind, is 3/4. 3/4. You might be like, what? Shocked. Absolutely shocked. I know. I know. Let's look at it again because you still might not all the way get it. So our twos are the same, which is why we went ahead and we chose the 3/4. But let's go ahead and use 4/8 as an example. So we'll draw our tenors from our 4. We know that with the 2, that with 4, you multiply 2 times 2 to get 4. Other than 1 times 4, this is the only thing that we could use to get 4. So we'll do the same thing with the 8. Since we have a 2 as one of our factors up at the top, we'll use a 2 down here at the bottom. What is multiplied times 2 to get 8? And that is 4. So our new fraction would be 2/4. But here's the problem. Can this be reduced even further? Yes, it can. Some of y'all are already screaming the answers, and I can hear you through the recording. But yes, 2 is a prime number. We can only multiply 2 by itself, right? But with 4, we can multiply 2 times 2. So our 2's are the same, just like they were over here. They're both of the numbers are divisible by 2. So our new fraction will have to be 1/2. And this, everybody, is our least equivalent fraction. Now for this, we probably had to go through more steps than we would have in any other problem. But for this, I think this will actually work. This will be pretty good. This worked for us. Let's try another example. Let's try 3/6. I know you're like, man, you keep on using these things that equal 1/2, but I'm just trying to show you the barest form of how we could use our understanding of prime and composite numbers and factor trees in order to reduce our fractions. So we see that 3/6, the 3 is a prime number, but the 6 is not. Can this actually be reduced? I don't know. Let's see. 3, since it's prime, can only be multiplied using 3. Using 3 and using 3 and 1. So 1 times itself. But the 6 can be multiplied, and it'll give you can multiply 3 times 2 to get 6. Since the 3's are the same, our new reduced fraction would have to be 1/2. So some of y'all are like, all you using is 1/2, Mr. Parker, to show us this. Yeah, I am using 1/2, but that was just the first 3 examples. So let's jump down into something like 18/32. We're going to use, since both of these are even numbers, we know that both of them are divisible by 2. So I put a 2 on both sides, at the top and at the bottom. But what can 2 be multiplied by in order to get 18? We know that 2 times 9 gives us 18, and 2 times what gives us 32? Well, we'll have to actually just divide 32 by 2 if you don't know already in your head. I know some of y'all, like I said, are screaming through the video, but 2 times 16 would give us 32. So what is our least equivalent fraction? Since we have a 2 at the top and a 2 at the bottom, we know that our least equivalent fraction would have to be 9/16. 9 over 16. Do I have another example down here? I sure do. Let's do 9/12. So other than 1 times 9, to get 9, we know that 9 is a composite number because we can multiply 3 times 3 to get us 9. So since we have 3 in our factors up top, let's go ahead and use a 3 down below. What multiplied times 3 will get us 12, and we know that that would have to be a 4. So we have a 3 at the top, a 3 at the bottom, and a 3 and a 4. So our new reduced fraction would be 3/4. But let's look at the number 3/11. We see that 3 is a prime number. The only two things that you can multiply to get 3 are 3 and 1. 11 is a prime number, so we can only multiply 11 times 1 to get 11. The only common multiple at the top is 1. So let's go ahead and scratch out our 1, and let's take our fraction and we come up with 3/11. Why did that happen like that? Well, because 3 is prime and 11 is prime, there is absolutely no way for our fraction to be reduced any further because 1 is the loneliest number that you'll ever know. So be ready in class. Oh, let me go ahead and give y'all some Toyo questions to work out in class. Try on your own. So I'm gonna ask y'all to reduce 6/9. Y'all should go ahead and try to reduce 12/14. Try a number like, let's try 2/12. And for number 4, we'll try a number like 8 over 18. All right, see y'all in class.